Hi guys, I'm back with another example on the derivative of trig functions. Guys, so far we have covered two examples. Here you can already see that we are kind of stepping it up. Here's a composition of several functions, and right away we can see that it's a sine cube of a function. So guys, in order to actually find the derivative of this function, we might need to actually go through like many different steps, and we may have to use the chain rule and many other different rules as well. So in order to find the derivative of this thing, first I'm going to write it in a slightly different form, which I like to think of as a more user-friendly way. So I'm going to rewrite this as sine, and this is going to be the same, the cosine, whatever is inside this, x cubed plus 2x squared, and I'm going to raise this whole thing to the power 3. So we should already know that the sine cube of any angle or any value here is same as the sine of that whole thing raised to the power that particular exponent. Okay. So if you have not watched my prior videos, guys, please watch my video where I talk about the fact that sine square x is same as sine x whole square. They are basically equivalent. They are the same things, but expressed in a slightly different way. Guys, keep in mind, most of the times, almost all the time in the textbooks, you would find this form rather than just the whole thing raised to the power 2, or for that matter, raised to any exponent. But guys, they are basically the same. So in this, or for this particular example, once I write it like this, it is easier for me to now start writing these steps or start trying to find the derivative of this function. So guys, using the chain rule, and this is how I like to do this, I consider this whole thing as just a big X. So it is x to the power 3 or x to the power n. How would I find the derivative of that? Obviously, we will use the power rule, and then we have to multiply by the derivative of the inner, which is like using the chain rule. Guys, you know power rule and chain rule, they kind of go hand in hand. So to write the y prime, first we have to bring that 3 in the front, and then whatever is inside the parentheses, I have to just rewrite the whole thing, but I have to raise it to the power n minus 1. So it's going to be sine of and cosine of whatever is inside. I have to write that whole radical, x cubed plus 2x squared, close that, and raise to the power 2. Why 2? I'm using the power rule, n minus 1. 3 minus 1 is 2. But guys, we cannot stop right here. We got to multiply this by the derivative of the inner, which is just simply using the chain rule. So d over, and I'm going to write all the steps, it's d over dx of this whole thing inside the parentheses. So basically I have to just write the whole thing in this step. Cosine of, guys, this is not too difficult if you ask me, but it requires a lot of steps. So one has to like write out all the steps carefully and be careful while actually executing each and every step. I don't have too much room here to write everything in one go. So guys, I will be like taking off some stuff and then rewriting things. But I think I have enough space to go to the next step. So from here, guys, this whole thing, I just have to rewrite this. I don't have to do anything with it. I know we cannot really do much with it except for just rewriting it. So I'm just rewriting that piece. X cubed plus 2x squared, this whole thing raised to the power 2. Guys, again, to do the derivative of this function, now if I look at the first thing that I like to check is what is the exponent, or what is sine raised to the power, because sine is the expression, or sine is the function which is outside. So I have to first look at that outside function. I can obviously see, or we can obviously see, that it is raised to the power 1. So when it is raised to the power 1, all we have to first do is we have to see what is the, or we have to go back and see what is the derivative of a sine of any angle. And we know that the derivative of the sine is just the cosine. So again, to actually write the derivative of this function, we have to start with knowing what is the derivative of the sine. And then if we have something different than x inside the parentheses, which I also like to think of as the inner, then we got to multiply by that derivative of that inner. Okay. So derivative of this is going to be cosine of this whole thing, whatever is inside in the parentheses. If it was just an x, only an x, then the derivative of sine x is cosine x. But now this is more like a combination of different functions, or a composite function. So we got to write the whole thing. So it is cosine of radical x cubed plus 2x squared. Oh, I love this problem. It is like it is really fun finding the derivative of so many different, because it's a combination of so many functions. So guys, then I have to multiply, because we cannot just stop right here. We have to multiply by the d over dx of the inner, right? Guys, what is the inner here? This was my outside function. So I already took care of that. It's the cosine of that angle. But then my inner, guys, my inner is this function, the cosine function. So cosine of, and let me put it in the parentheses, x cubed plus 2x squared And that's it, got to close that. Guys, look carefully. First, I rewrote it in this form, so it's more user-friendly, more easier for us to now look at that particular form and see, hey, this is more like an x to the power n form. We can use the power rule on it, and of course, it's going to be a chain rule as well, because it is not just a sign x by itself. It is raised to the power 3, and there's so much going on inside as well. Guys, this particular problem is like a composition of so many several different types of functions. So that's where we have to like keep on multiplying by the derivative of the inner as we move from one step to the other step. So then we did this first using the power rule, but then we realized that we still have to multiply by the derivative of the inner. Derivative of the inner is just whatever is inside the parentheses. So look at this big parentheses. This whole thing, we have to find the derivative, or we have to write the derivative of this whole thing. In this step, I just wrote the notation of that. In my next step, now I'm trying to execute that step. Guys, this thing, we don't have to do anything with it. We just have to rewrite it. Then derivative of this, it is pretty much not too complicated because nothing is squared. It's just to the power 1. So all we have to start with, hey, what is the derivative of the sine function? The derivative of sine is cosine. That's why we wrote this cosine here. And this is exactly what is inside those parentheses. Whatever that x value is. In this case, it's not just x, it's more than an x. So we wrote that, but we cannot stop right here. We have to multiply using the chain rule. We have to multiply by the derivative of the inner. So guys, the derivative of the inner here is just this piece inside the inner parentheses, which is the cosine of the radical x cubed plus 2x squared. So you can already see what is going to happen in the next step. So guys, this is already done. Now all we have to focus on is just this piece. So let me get rid of some stuff from here so that we can actually figure out the rest of the derivatives here. So I'm going to get rid of this basically, and then guys, let us guys, if you can like understand and do this problem or this type of problem on your own, I mean, you can do any problem on using the chain rule or anything involving the trig functions, because this is like too many steps and too many compositions going on here. So from here, guys, this whole thing I just have to rewrite. So I'm going to, maybe you know what, I'm going to get rid of this as well. I need more space here, so I'm going to get rid of this as well. Let us at least leave the functions, the heading here. So from here, guys, I'm going back here. So I have y prime equals to 3, and then I just have to rewrite most of the stuff. Sine of the cosine of radical x cubed plus 2x squared whole square, this whole thing squared, right? Let's be careful, because there's a inner parentheses here, and then you have to close the outer parentheses, and then you have to multiply this guy by the cosine of this. Cosine of the radical x cubed plus 2x squared, and then guys times. So I cannot squeeze everything in one line, so we got to go to that next line. Guys, derivative of this. Again, this is not too complicated. It is just basically finding the derivative of just the cosine function, because cosine is raised to the power 1 only, right? So we know the derivative of a cosine function is negative sine, right? And here we don't have just x, we have a radical of this whole thing, so we have to multiply by the derivative of that inner. So let me put this in parentheses so we can see that there's this derivative of the inner. So we're going to multiply this by the sine of the whatever is inside here. Here I don't have an x, guys. If I had just x, then I would say it's okay. I have to multiply by the negative sign, because the derivative of cosine is negative sign. Let's be careful with that. And then I just have to rewrite this, whatever the value is here, x cubed plus 2x squared, and then we've got to multiply by d over dx of the inside piece or inner piece, which is just the radical of x cubed plus 2x squared. And let us close the parentheses as well. So guys, we're getting very close to actually finding the derivative of this whole function. So guys, moving on. Now we got a lot of these terms. They're all multiplied, keep in mind, but they're not like terms. We cannot really multiply them. All we have to do is we just have to write them next to each other. Guys, I'm going to just take out this negative outside here. So it's going to be -3, and after that, I'm just rewriting these terms. I mean, we have to keep on rewriting them. Sine of the cosine of square root of x cubed plus 2x squared, and then raised to the power 2. There's a lot of terms that I have to write. Then times. You know what? Maybe I should have, because I need more space for this. So this was this step. Now moving on, guys, this is going to be 3 times, and let me try to write in the rest of this, sine of the cosine of radical x cube plus 2x square, and you got to close the parentheses, square it. I'm just rewriting it, guys. I don't have to do anything with the first 3 terms. All I did was this negative, I just bring this negative up front. So it's going to be negative 3 right here, and then I'm just going to write the rest of the terms. Cosine of radical x cubes plus 2x square, close that, right? This term, it's negative 3 times this term times this cosine of this whole thing, and then I have the next term is sine of radical of x cubed plus 2x square, right? That takes care of this term, and then we just have to multiply by the derivative of this function. Now derivative of this function, we can consider this, so let me see, I have to get more room again, so I can get rid of this. So finally we'll be able to squeeze in the final answer. So guys, times the derivative of this. To find the derivative of this, we have to consider this as x cubed plus 2x squared raised to the power 1/2. And for that, we have to just simply use the chain rule. First, we think of this whole thing as a big X to the power n. So you use the power rule and multiply by the derivative of the inner, which is basically executing or using the chain rule. So it's going to be 1/2 times x cubed plus 2x squared raised to the power 1/2 minus 1, which is going to be negative 1/2. And then you have to multiply by the derivative of the inner, and in this case I don't have to write d over dx. We can just actually simplify it and write the final answer. Guys, derivative of the inner, it's going to be 3x squared using the power rule on both, and then the 4x. That is it, guys. We have finally evaluated the derivative of each of the inner pieces. All we have to do at this step is we have to just rewrite this in a slightly nicer form, which we can do, and then we'll be done. So guys, y prime would be, what I'm going to do is I'm going to bring that 2 kind of up front, so it is negative 3 over 2, and then we like to bring the algebraic functions in the front, and then we want to write the trig functions. So what are the algebraic functions? I have this 3x squared plus 4x. I cannot take out any, I'm not going to take out any common factors. I'm just going to rewrite it like this: 3x squared plus 4x. And guys, since we do not like the negative exponent, so if I bring it downstairs, it's going to look like square root of x cubed. All I did here was I just brought it downstairs in the denominator, and negative exponent changes to a positive exponent, so it is x cubed plus 2x squared. That goes in the denominator. That's it for the algebraic functions. Guys, all we have to do now is we just have to rewrite the rest of these trig functions in a straight line, and that's it. That would be our final answer. So I'm going to carefully write this. It's a sine of the cosine of square root of x cubed plus 2x squared, x cubed plus 2x squared, and then square it, right, times the cosine of the, I'm just rewriting the whole thing, cosine of the x cubed plus 2x squared. And then guys, there's still times. I could not squeeze everything in just one line, so I have to write it in this one. Second line, sine of the radical of x cubed plus 2x squared. Guys, this is my final answer for the derivative of this function. Yes, it was a lot of steps. Guys, you may have to go back and look at this this whole example carefully, maybe once or maybe 2 times. But guys, then I would like you to try and do this. Once you look at all solution steps and try to understand the conceptual way of kind of thinking about these things. It is just starting with the idea that it's just the power rule kind of a thing, and then you have to keep on applying the chain rule. Guys, finally, this is the final answer. So once you look over the solution methods, guys, please try to do it on your own. And when you do it, when you are able to do it on your own, then you will be more confident with these type of equations, or this type of examples. Okay, guys, I will see you in the next video with another example. Till then, take care.